All right. What's this?
I reposted your front page or output page. No, I am one.
All right. Here we go, people. Okay, so you took your test number 3. You joined AP Classroom. Did you do it? No. You didn't join? Yes, you did. Oh, little silly guy. All right, so today's homework is the first homework that's going into quarter 2.
Yeah.
Okay, so let's put Chromebooks to the side for now, please.
Hi guys, the extreme love
Rodrigo says hi. Okay, so today we're gonna learn products and quotient rules. Hopefully these notes shouldn't take forever because I think this is a little bit of an easier topic, so we're putting Chromebooks away for right now, please. And then just for a little heads up for Wednesday, I have another little sonogram. So you guys will be in Miss Heath's room right next door, and you'll be having to do video notes that day. And I'm very sorry, I'll miss you very much. No, next B day, which is or A day, which is Wednesday. Uh-huh. Yep.
About pencil?
Yes. All right, here we go. All right, the product rule. Okay, product rule is going to be used to take derivatives of products. So what operation is a product? Is it plus, minus, times, or divide?
Times.
Times, very good. So put d dx.
dx.
That means derivative. Okay, and then of f of x times g of x. Okay, so you are only using product rule when you're taking the derivative of a product, which means it has to be multiplication. Okay?
What does d dx stand for?
d dx just means take the derivative. Okay? So here's the rule. Write it down. It's f g prime plus g f prime. Okay? And then you should know that f to f prime means you took the derivative. G to g prime, you took a derivative.
So it's f of x times g prime x?
Uh-huh. Plus g of x, f prime x. Now, if you looked in a calculus textbook, that's what it would say. Okay, but we're going to do sort of a shorthand notation so that you don't have to like write it out like that every time. So d dx, bless you, u times v. Okay, where u is the first part of the product, v is the second part of the product. And then it's going to be uv prime plus v u prime. Now, technically, okay, these are just different ways of writing the same thing. Okay, and the only reason I'm doing the second one is because it's a little bit shorter. What do you need to do? You can't do them during class. You'd have to stay after school, or you can do next time. It's fine. Is what I had talked to her about. Yeah.
I go home.
Huh?
I go home.
Yeah, I'll clarify with her. I think she might have been confused. Uh-huh. All right, so take a look at number 1. It says that f of x is 3x squared sine x. That is a product of 3x squared times sine. So 3x squared is the u, which is the first part of the product. Okay, and then sine x is the v. So I want you to write u equals 3x squared. V equals sine x. Okay, then you're going to take the derivative of both of those parts. So, for example, 3x squared, do we know the derivative of that?
6x.
Okay, 6x, very good. What about the derivative of sine x? Cosine, good. Okay. And then from there, you're gonna do diagonal plus diagonal. So let me show you what I mean by that. I want UV prime first. That's this diagonal. And then plus VU prime is this diagonal. Okay, so right over here to the side, put Y prime equals. UV prime would be 3x squared times cosine x plus, and then VU prime would be this diagonal, so it'd be sine x times 6x. Now, I do want to point out something to you. Okay, multiplication and addition, okay, they're commutative. What that means is it doesn't matter if you put this one first or this diagonal first. As long as you get both of them with a plus in the middle, that's all that matters. Okay? So for your homework, this is perfectly good enough. But for the AP test, if there's a GCF, typically they'll pull it out. So a 3 and what else? An x. So I'm going to pull the 3x out. That would leave me with x cosine x plus what? What would be left from the 6x if I divide by 3x? 2 sine x. Go ahead. Okay. Now, also keep in mind that you cannot take the x's out of the sine and cosine. That's just not a thing. So don't do that. Okay. All right. But for your homework, this first one is perfectly acceptable.
Will they also accept the second one?
They would count both of those correct. All right, let's take a look at number 2. Underline the parts of your product. This is a 5x times an ln x. And then we're going to take the derivative of both of those parts separately, then do a little cross multiply plus for the derivative. So if u is a 5x, what's the derivative? 5. Good job. If v is an ln x, what's the derivative? 1 over x. And then remember, it's diagonal plus diagonal. Doesn't matter which one you do first. Okay, I'm going to do this one first. Okay, but again, it really doesn't matter. So y prime equals 5x times 1 over x plus 5 times ln x. Now, in that first term, if I have a 5x and a 1 over x, what could I do? Just pretend just that term. Yeah, the x's are going to cross out because you have a times x on top and a divide by x on bottom. So then all that would be left is 5 times 1, which would just be a 5. And then is there a GCF I could pull? Yeah, 5. So you could also rewrite that as 5, 1 plus ln x. Okay? But remember, both of those are correct for your delta math. The first one's 5. But for AP, usually they'll take a GCF out if there is one.
Oh, you don't add the 5? The other 5?
You could not, because they would have to both have an ln x for you to add them together.
I thought it was 5 times ln x.
It is, but we GCF'd the 5 out of both. That's how it got to the outside. So if these both have a 5, I just pulled it out. So 5 times 1 would be 5, and then 5 ln x, if we times it back in.
Right.
Okay? All right, take a look at number 3. Write your products. My u is an 8 root x. My v is a cosine x. Now, in order for me to take the derivative of the root x, do you remember how we should rewrite it? Very good. So I'm just going to cross out the square root and put a half, just so I don't have to actually rewrite it. Okay, but you should know that those are the same. All right, let's take the derivatives. So I do half times 8. What's that? 4. And then I need to take away 1, but I'm going to do it as a compatible fraction. So it's a 1/2 minus 2 halves, negative 1/2. Let's see.
Hey,
Okay, so half times 8 is 4. 1/2 minus 2/2 is -1/2 powered. Now for my v prime, I'm taking the derivative of cosine. What kind of sine x? Negative. Bless you. And then we're going to write our derivative. Now, for this derivative, instead of calling it y prime, which is still correct, I'm going to call it dy dx. Okay, and the reason why is that I want you to get familiar with the fact that y prime and dy dx are the exact same thing. Okay, both of them mean you took a derivative. So we're going to do this plus this. So I'll have 8x to the half times negative sine x plus 4x to the minus a half times cosine x. Okay, from there, go ahead and switch that back into radical form. Charlie, go ahead and sit right there, honey. For the first x to the half, will it go top or bottom as a square root? Top. Where will this one go? Bottom. So it'd be 8 root x. And then if I'm multiplying that by a minus sine x to avoid this looking like subtraction, I'm going to go ahead and multiply it onto the 8. So it would be like that. Okay, and then for my second term, it'll be 4 over square root x, and then the cosine will join the x on top. Okay? Then from there, okay, if you look at your notes here, or your instructions, it says write your answer as a single fraction with a common denominator. So if my second term has a root x on bottom, my first fraction has to be the same. So I'm going to put a root x here. Bless you. And I'm going to also multiply 1 on top. Yeah, sure. And then what is the root x times the other root x? A full x now. Very good. So that'd be a minus 8x sine x plus 4 cosine x over square root x. Okay, just like that. Okay, but again, your homework, most of the product rules say take the derivative and write it in any form. So even if you left it like this for your homework, it would be fine. Okay, this would only be if you're trying to match a multiple choice answer on the AP test. Okay, go ahead and turn the page. Little silly guy.
we're doing the whole difference.
Yes. You go turn. And then if you want to kind of over. All right, turn the page. But look, it's only 2 pages, kind of short, you know. All right, underline your pieces. My u is an x squared minus 8. I'm multiplying that with an e to the x. Okay, then we're going to take both of those derivatives. What would u prime be?
2016.
2x, yes. Okay, minus 8 would go away. What about v prime? E to the x, the derivative is still e to the x again. Very good. Okay, then go ahead and write your derivative. I'm going to call it dy dx again. Okay, but remember, that's just another way of saying derivative. And then the order doesn't matter as long as you put both of them. So I'm going to put this one first. X squared minus 8 times e to the x plus 2x e to the x.
How come u prime is e to the x?
E to the x is its own derivative. That's one of your special rules. So when you take the derivative of e to the x, it's still e to the x.
No, but what about the, oh, I see, never mind, sorry, I confused it.
Okay.
The prime is underneath.
Yes, yes. Now, one other thing, if you typed this into Delta Math, it would count it wrong. Here's why. If you have a piece of your product that has more than one thing in it, so what I mean by that is like this is an x squared minus 8, you have to group. What this says right now is x squared minus 8 times e to the x. That's not what I want. I want this whole thing to be times e to the x. So make sure that if you have a piece with more than one thing in your product rule that you apply those parentheses, okay? Now, do we have a GCF that we could pull out of those?
2x.
Can't
No.
take out a 2x.
2.
Nope, it's a letter. They both have an E.
Oh, yeah. That's right there.
Yep, that's okay. So we're going to go ahead and take that e to the x out. My first term would just be left with an x squared minus 8. And then my second term would just be left with 2x. Okay?
So it'd be x squared minus 8 plus 2x?
It'd be x squared, yep, minus 8 plus 2x, correct. Okay? But if you have a GCF, you should know how to pull it out, but it's not required for your homework. Okay, one more left. Put a little star on number 5. Yes. Huh? And then we'll have no lights. So I'm gonna say no. I think we only have one on. All right, take a look at number 5. Here's where you're likely to mess up on number 5. This is not this times sine x. What is the only thing that's multiplied with sine x? The 3x squared. So make sure that this term is not part of the product rule. Okay, the 10x3 is kind of chilling on its own. Okay, then I have a minus with a product of the 3x squared times the sine x. So let me show you how to work this question. There is a couple like it on your homework. Okay, my u is going to be the negative 3x squared. And my v is going to be the sine x. So my u is negative 3x squared. My v is sine x.
Wait, how come the 10 is not part of it?
Because it's not included in parentheses that all of that is multiplied with sine. It's just the 3x squared part. Okay, go ahead and take your little derivatives. What's up, Amberly?
Test reviews.
I have no idea. If it's on focus, then yes. If it's, would you just like a blank copy of it?
Yeah.
Derivative would be negative 6x. And then what about the derivative for the sine x? Go ahead and write that down. Here you go, honey. And then keys on school. So sine goes to cosine. Okay, so now let's write our derivative. Now remember, this is the product rule that's going to replace this product. Okay, but the 10x3 is not part of it. So let's write the derivative. Your y would go to y prime. Or if you want to call it dy dx, that's fine. Okay, and then you would take the derivative of 10x3. What would it be? It's just a regular derivative, 10x3, 30x squared. And then I get to the product rule part, and I do diagonal plus diagonal. So I'm going to do this one first. It'd be a negative 3x squared cosine x plus, and then a negative 6x sine x. Okay, but make sure that the 10x3, that's just a normal derivative. So this is my product rule, but the 10x3 would go to a 30x squared just like it always would have. Okay, because it's not actually being multiplied by anything. Okay? Let's clean that up a bit. The 30x squared is going to stay the same. This is now a minus 3x squared. And then this would now be a minus 6x sine x. Is there a GCF that all of those terms could divide by? Very good, 3x. So my 30x squared would now be just a 10x. My 3x squared would now be just x cosine x. And then a minus 2 sine x. But remember, both of those are correct. Okay, it's really just on the AP test, making sure that you can find the right answer when you've done it. Okay? So product rule is for taking the derivative of stuff that's multiplied. Okay, what does a quotient mean? What rule? Division. Very good. So you're going to use quotient rule for division. Okay? So product rule is for multiplication, quotient rule is division. Let's write your rule down. Okay, I'm going to give it to you in two forms. The first one is going to be like the textbook. Okay, and then the second one's going to be the shorthand that we're going to use. So quotient rule says this: the derivative of f over g, okay, where f and g are divided, is g of x, f prime of x, minus f of x, g prime of x, over g of x squared. Now, in a textbook, it's also going to say that your g of x cannot be equal to 0. Now, where does g of x end up in the fraction? In what part? The top or the bottom? And remember, why does it make sense it can't equal 0? Because you're not allowed to have it divided by 0 on the bottom. Okay, so if you see that in a question, that just means you're dividing and you're not allowed to divide by 0, so they just have to say it. Okay? All right, here's your short version though. So this is the long version that you'll see in a textbook. Okay, here's your shorter version. It's going to be derivative. We're going to call the top high and the bottom ho. Okay, so it's high over ho. Okay, your quotient rule is going to be ho d high minus high d ho over ho squared. And then the reason you can remember this version easier is because the ho's go on the corners. Okay, so then you don't have to remember which way it goes. Okay, the ho's have to go on the corners. So that's how we're going to do it. All right, so once you have that written down, let's do number 6. Okay, the high is the top. What is the top function in my fraction? Cosine x, very good. Okay, that's the top. And then ho is the function on the bottom, which is a 4x. D high and D ho are just going to be the derivatives of those. So if high is cosine x, what's D high? Cosine goes to what? Negative sine x. Very good. Okay, and then if ho is 4x, what's D ho? Just a 4. And then we're going to follow our formula right here. Okay? So remember, when you subtract in quotient rule, the order of the diagonals that you do does matter. Okay, remember, for addition, 3 plus 5, 5 plus 3, same thing. But for subtraction, that's not true. So you have to do ho d high, gentlemen. Okay, ho d high first, then minus high d ho. Okay, so let's write it out. dy dx equals ho d high would be 4x times negative sine x. Okay, quotient rule is minus in the middle. And then high d ho would be cosine x times 4. Oh, wait, hold on. Yeah. Okay, then all of that over ho squared, which is 4x squared. Okay? All right, for your quotient rule questions, it does not say you can type it in any form. It says it has to be in simplified form. So what that means is you just need to times the tops out. So here, my 4x times minus sign would be a minus 4x sine x. And then cosine x times 4 would be a 4 cosine x. Okay. Then on the bottom, 4x squared would be 4x times 4x again. What's that? 16x what? Squared. Okay. Now, quick question. If this were the AP test, they're not going to leave GCFs in. What can every single one of those coefficients divide by? Can I also divide an x out? Yes or no? No, because remember, cosines x, you can't take it away. So I would divide all of those by 4 if I had to match an answer. So your final answer, I'm going to have to go backwards because I wrote too big. Okay, but if they can all divide by 4, that would be a minus 1x sine x, a minus 1 cosine x, and my 16 is now a 4x squared. Okay, but for delta math, it'll still take this. You only need to kind of worry about these simplifications if it's a multiple choice and you want to match your answer to a presented answer. Okay? All right, you're doing great. We're on number 7. Okay, write down your high and your ho. Remember, high is the top, ho is the bottom. So high is the top, ho is the bottom. So for my top, it's a 2x3 plus x. And on bottom, it's an x squared minus 5. All right, go ahead and take both derivatives. So remember, the derivative of the top is d high. The derivative of the bottom is d ho. So derivative on top, what are we going to get? 6x squared plus what? Plus 1. Very good, because remember, the x would drop off, but the 1 would stay. Okay, for my d ho, what's the derivative? 2x, 5 goes away. Then remember, it has to be ho d high minus high d ho, because the ho's want to be where? On the corners. Okay? So, write out your derivative. We're going to call it y prime this time. So, ho d high would be x squared minus 5 times 6x squared plus 1. And then high d ho would be 2x3 plus x times 2x. Okay, ho squared on the bottom is an x squared minus 5 squared. Rodrigo, you good over there?
Yeah.
Okay. Now, for your homework, okay, remember what I said. Product rule, it says in any form that you want. Quotient rule, the questions make you put it in simplified form. So what that means is you're going to have to times these little top parts out. So I'm going to have to multiply this together, and then combine like terms. So let me show you what I mean by that. We're going to double distribute. What is x squared times 6x squared? 6x to the 4. Very good. I'm just going to write it right on top so I don't have to rewrite the whole thing. Okay, what about x squared times 1? It should be a 1x squared, yeah? Okay, now we're moving to the minus 5. We're just foiling this out. Minus 5 times 6x is a minus 30x. Oh, and that was actually a squared. Don't forget your squared on there. And then what about minus 5 times 1? Minus 5. Now, for your second term, I'm timesing in a 2x. But at the same time, I need to remember this is subtraction. So what I'm going to do to make that easier is I'm going to turn this into a plus and let the negative be multiplied in with a 2x. So there needs to be a minus somewhere, but so I don't forget it, I'm going to put it here so that I can share it into my second parentheses. What is minus 2x times 2x3? Minus 4x, 4 now, right? Because we brought this x in with the x cubed, bumped it up a power. And then negative 2x times x is a negative 2x squared. Okay, then from there, only the top, you're going to look for like terms that you can combine. So let's do the x4s first. We have a 6x4, and what else? And a negative 4x4. How many are going to stay? Okay, 2x4. Okay, now let's do our x squareds. So we have 1x squared with a minus 30. How many is that? Minus 29, and then I have to minus 2 more. So minus 31x squared. Okay, and then the minus 5, no other numbers to go with that, so you would just leave it. Okay, for the bottom, they're just going to leave it alone usually. Okay, so you would have to times out the top and look for like terms that can be combined, but the bottom, you're good. You should be able to just leave it. Okay, do we feel like we could maybe skip number 8 since it's quite similar? Yeah. Okay. You're going to have several of those to practice on your homework. If you need help, just ask me. Okay, let's go down to number 9. Number 9, it asks you to write the equation of the tangent line. Okay, but we're just going to settle for taking, fine, we'll do it. Okay, what do we need for an equation of a tangent line?
Point and slope.
Oh, good job. That's right. Okay, we need a point and a slope. Okay, for my point, what do I know about my x value? Okay, what do we know about our x value? Okay, it's 0. So 0 comma something. Okay, then remember, when you took your test over this, you should have known that to find the y value, you plug 0 into the original. Okay, so if my x is a 0, I'm going to plug in a 0 to this guy. So it would be cosine 0 over e to the 0. Okay. All right. What is cosine 0? What is e to the 0? What's 1 divided by 1? 1. Now we're ready to take the derivative. Good job. And for me to take the derivative, because it's a quotient, I'm going to have to use quotient rule. So since we skipped number 8, I'm going to use that space to set up my quotient rule. Okay, but I'm going to put right here, this needs quotient rule. Okay, why? Because my function is stuff that's divided with each other. Okay, so my high is a cosine x. My ho is an e to the x. And then remember, you're going to take both little baby derivatives, then do ho d high minus high d ho over ho squared. So what is the derivative of cosine x? Okay, negative sine x is correct. What's the derivative of e to the x? Okay, and then let's write our derivative. So my original function is f. Then remember my derivative is called f prime. And then remember, you got to go in order. It's ho d high, that's this diagonal, minus high d ho. So it'd be e to the x negative sine x minus cosine x e to the x. And then ho squared would be e to the x squared. Now, if I didn't have a number to plug in, I would look for a GCF. Okay, but what X am I plugging in here? 0. So I'm just going to go ahead and plug a 0 into all those spots and then think about what's going to happen. What is e to the 0 for this first term? That's a 1. What is sine of 0 for this term? Sine of 0. It'd be 0 because you're already on your pinky and you don't have any fingers below that. So that would be times 0. What's cosine of 0?
1.
What's e to the 0?
1.
So that'd be 1 times 1. Okay, then on bottom, what's e to the 0? Not e to the 0 is 1 squared. Okay, then remember that your 1, if you're multiplying it by 0, that's going to just cross out. So I have negative 1 times 1 is negative 1. Over another 1 is negative 1. So we have our point, we have our slope. Then our equation of our tangent line is y blank equals blank x blank. Remember your slope goes in the middle? Okay. My x is a 0, so I'm just going to put minus 0. My y is a 1, so minus 1. Okay?
Yeah. Like, opposite positive or just opposite?
Think about, it depends if it's either or not.
Well, yeah.
Give me one. I have to do one more question with them and then I'll give you some help. All right, turn to the last page. Okay, last one that we're going to do is number 11.
Oh.
All right, last one, number 11. Okay, you have a couple questions like this towards the very end of your homework. So that's why we can't really just skip it all together. Equation of a tangent line, what 2 things do you need? Okay, point and a slope. Okay, and you'll notice that you have a chart with some stuff about F in it. Okay, you have questions just like this on your homework. So when you're doing the point, remember you're going to plug into the original. But when you're doing slope, you're going to use the derivative. So when I'm plugging into the original, what is my x value that they gave me here? 0. So it's 0 comma something. And then I'm going to plug that into my function, but my function is cosine x times f of x. So it's going to be cosine of 0 times f of 0. What is cosine of 0? 1. And then f of 0, you're going to use the chart. So come over here to 0. What's f? 3. And then 1 times 3 is 3. Okay, then after I find the point by plugging into the original, I need to plug into the derivative. What rule am I going to use? Product or quotient for this question? Product, because what's the operation between cosine and f? Multiplication or division? Then I need to use product rule. Okay, but if they were divided, you would be using quotient rule. Okay, so let's set it up. My u is a cosine x. My v is an f of x. What is u prime? Negative sine x, thank you. What is the derivative of f going to be called? F prime, very good. Okay, so notice that if you have a regular f and you take the derivative, it's going to bump it to f prime. Okay, and then you're still doing diagonal plus diagonal. So for my derivative, we'll do this cosine x f prime of x plus negative sine x times f of x. And then because we're plugging in a value, a number, I'm not going to try to get a GCF or anything. I'm just going to start pulling numbers. What is our x? What number? 0. So we're going to put a 0 here, 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 and here. What is the cosine of 0? 1. What is f prime of 0 using the chart? -2. What is sine of 0? 0. Which means that f of 0 times 3 is going to basically just cross out. So 0 times 3 is 0. Add that to 1 times -2 is -2. That would be your slope. Okay. Then from there, remember your delta math will take it in point slope form. So it'd be y blank equals blank x blank. -2 is your slope that goes in the middle. Your x was a -0, your y -3. Just like that. Can you do it? Good. All right, so you have about 40 minutes. Okay, so I'll bring you some scratch paper. Yeah.
Can I use the restroom? Put in the water bottle?
Yeah.
Hey, wake up.
Okay, Carly.
Yes.
So I want you to think about x squared as your even. If it's a positive x squared, which way do your ends go? Both up. What about a negative x squared?
Yeah, that's good.
Okay, so an even positive, both ends up, even negative, both ends down. Now let's do x for your odd. If it's positive x, is it an uphill or a downward line? Positive x is an uphill line, so it should start at low and high versus what would negative x do?
Start high.
Exactly. So it depends if it's a positive or negative and an even or odd. You care about both of those.
So with for the leading coefficient, would that be the x?
That would be the positive or the negative in the front of the x. All right, then real quick, y'all, I'm not going to do this first one with you, but I just want to remind you, okay, what is the product for this first question? This is the U, this is the V, but it says in any form. So don't try to like fix the negative exponents. Just take the derivative of both pieces, write the cross product. Okay? But you don't have to do a bunch of simplifying. If it says in any form, you're going to write both pieces, take both derivatives, diagonal plus diagonal. Okay? You can do it. You can do it with the silly sleepy guys. Yeah. Ooh, I got you. Allie, do you want some scratch paper? Yeah. You want some paper? Did y'all already cover product quotient? Yeah. Can you see? There you go. I'll show you guys some paper. You want that? And then your first several questions are the same if you want to kind of check your work with your people. These are good questions. Uh-huh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120 Okay, so 4 from the right side, what is the graph? Okay, good. So if I cover up the left side, I'm only looking at right. Which way is it going as I get closer and closer? Up or down? From the right side, correct. So we have a little plus. Up to what? Right? So then I would take infinity and I would apply that to the x value for x. Okay, and x to infinity means you're tracing all the way to the right end to see what that side is doing. What is it right end? So, oh, I forgot, this is like, what should be minus. Yeah, it should. Yes. That is exactly right. Correct. Very good. Charlie, you done? Perfect. Thank you, dear. Have a great day. Yep, see you tomorrow. Would this X go on the bottom? Don't, I would just type it in for this. He went to the water. Yep, that's the first part. Well, that's perfect.
What you guys are? That's not that stolen. Actually, wait. Forgot to ask you.
What's that?
Still possible corrections for the first test.
The only way would be if you came in today after school.
I'm gonna do that if that's okay.
Okay, yeah, that's fine. Saida, you get to keep this through this section. Alright, let's see. We did first derivative second plus second minus shouldn't that be a ton of 4? This one, the derivative, so it'd be a 6x squared minus, that'd be a 24x. And then negative, yeah, that should be.
If you had word.
Did it kind of wrong? Oh, okay. Wow, but it's so silly. Yeah. A filled out one? I at least have one with all the examples we did together filled out. Might take me a moment to find it. Okay, this doesn't have every question on it filled out, but it has a lot of it. Okay? Uh-huh. Asha, yes, ma'am? Not until next week, yeah, but you will get a chance for that. Yeah, this is good.
I'm gonna take this.
Yeah, you need to use parentheses if there's more than one thing. So those both have more than one thing. Yeah, I just actually am still recording it, but let me turn it on. And I'll put it on YouTube. Do you want me to email you the link or just put it on school?